everyone. Welcome back to my teaching video today again. In this video today, I would like to show you the last rule in our derivative rules, which is the chain rule. Now we have went through the first rule is power rule. Then we went through product rule. And then the third one is quotient rule. And now the last one is chain rule. So what is the chain rule? The chain rule is the application of the derivative of the composite function. So in Math 12, we learned that sometimes we have a function outside and then inside there is another function. And we call that as the composite function. So the chain rule is the derivative of the composite function. So remember the notation when you learn in Math 12, we say this is f of g of x. So that is our composite function. So we have a g of x inside the f of x, and the notation we write like that. We read at f of g of x. Now there's another notation you can write like this as well. F of g of x of x, right? So that's another notation for composite function. So now let's see how we derivative the composite function. So if we have f of g of x, the g of x is the inner function. So the rule is we have to take derivative of the outer function first. So f of we take f prime of x times with g prime of x. And this we call derivative, right? The prime we call a derivative. So we take derivative of outer function f of x times with derivative of inner function g prime of x. Now, can we do revert? Of course, right? Because they are multiplied together. So doesn't matter 2 times 3 or 3 times 2 give you 6, right? So some people will afraid that we're going to forget. So why don't we be safe? We take derivative of inner function first. So g prime of x first to make sure we don't forget, right? Then we'll take derivative of the outer function. That is perfectly okay. You can do that as well. So let's say if I have another notation. Let gx equal the function of h of f of x. Find the derivative of g prime x. So g prime x will be equal h prime of x times with f prime of x, right? So that's another notation. Now let's do the example. How are we going to find derivative of this composite function? So you see that this is the inner function f of x, and all of them, there is the outer function, which is the f of x to the power 3. So now in this notation, let me go reverse. I'm going to take derivative of inner function first, right? So y prime will be equal f of prime of x, right? So I'm going to take derivative of this function. F prime of x. So I'm just take derivative of the inside function first. So I have take derivative this f prime of x, right? So I take care of the derivative of f prime of x. So this is this one. I take derivative of this one. Now I'm going to take derivative of the outside function. So time with 3 f. Inside, I still have an f of x. But this function now, instead of power 3, will become power 2. So this is how I do revert, right? So I take derivative of inner function. And then now I take derivative of outer function. So that is, if they ask you, they give you a notation like that, they ask you, take the derivative of this. This is how you do. Now, let's give you another example. Let's say if I have a function y equal t adding with third root of t adding with t squared, all of them to the power 20. So how do we do this derivative? So I'm going to show you on the next bar so that we have enough room, okay? And because I'm not going to show you more, so this is my last question. So be patient and bear with me. Watch me to finish how to do this derivative. So now this derivative will be y prime, right? Now in this case, it's easier for me to do the outer function first. So I'm not going to do the inner one. I'm going to do the outer first, okay? And then here I have t adding. Now I'm going to change this, become rational function so that it's easier for me to deal with the power in terms of the power. So I'm going to change this, become 1/3 power. And outside, I'm going to make this become 19, right? So now what next? Now we're going to do derivative inner function. So derivative inner function of t here is 1, adding, right? Now I'm going to do derivative this bracket, right? So that becomes 1/3 times with t adding with t squared. And the power will subtract 1, which is minus 2/3. So now, am I done? No, because you look at, there's another inner function. So we do the chain rule. So we have to take derivative of this outer function, also derivative the inside here, right, of this bracket, which is, we time this with 1, because derivative of t is 1. The derivative of t to power 2 is 2t. So now we're done. After we do all the chain rule, we take care of all the inner function like this, then we're okay. Now this is our answer, but let's make it a little bit nicer, right? Let's simplify it. I'm going to leave this alone, right? Except that I'm going to change this back to the third root so that it looks nicer. T plus t squared. And outside I have power 19. Now in this one, because this is the negative power, I don't want to leave it like this. So let's say, what do I do with it? I'm going to say 1 is just 1. Adding with, I'm going to multiply this bracket in here, right? So when I multiply this in here, this stay on top. 1 at 2t. Down here, I'm going to bring this down to the bottom, and I change the negative power become positive power. I also change the rational power become the third root again. And I have t and t squared, all of them to power 2. Remember, this one I bring down, it become positive, and the power is on the top, power 2, and the bottom is the root, right? So that's how the way we write it. And that's it. That's how you done. So I have shown you how we take the derivative of the chain rule using the chain rule for a very complicated function. So I hope at this point you will be able to do it on your own after you watch my video. Again, if you register in my course later on, you're welcome to have a meeting on Zoom with me. If you need help, need assistance, I don't mind to help you. But I think that I'm teaching very slow, step by step, and show you The question usually at the average level and higher. So I hope when I give you exercise practice, you won't have any trouble to do it. So that think positively. Okay, thank you for watching. Bye for now. See you in the next video.